Hey guys, we are going to start our probability and statistics units. We'll do probability first, and then after this we'll move on to statistics. So, last little leg of Algebra 2, and then after we do these units, we'll probably start doing some pre-cal stuff to get you ready, maybe some trig. So, we are in the last little bit. What we're going to do today is see if we can determine what the difference is between a union, an intersection, and a complement. Okay? So with probability, we're going to first start. Down. There we go. So we consider the sample space. Okay, so this is all about data, right? The sample space, the collection of all the outcomes. Okay, so my sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, how many elements are in S? So how many pieces are in my sample space? Okay, well there are 10 elements, right? Because we have numbers 1 through 10 in the sample space. So a sample space is all the data together, and elements are the pieces of data within it. Okay. Now we have certain events or subsets that exist within the sample space. So if my event A is even numbers, then how many elements of A are there? Well, if my whole sample size was numbers 1 through 10, which of those are even numbers? 2, 4, 6, 8, and 10, right? So how many elements are there? There are going to be 5. Oops, sorry. It's going to be just the even numbers, so there are 5 elements, and the elements are 2, 4, 6, 8, 10. Okay? So what are the elements of event A? Well, that's going to be what are the even numbers. Next, let's list the elements of event B. Event B are numbers that are less than 5. So we're going to list all the values less than 5. Well, that's 1, 2, 3, and 4. Can't include 5 because 5 is not less than 5. 5 is 5. And those are all the elements that are less. Right? Now, what we're going to do mostly today is represent all of this with Venn diagrams. Okay, so a Venn diagram can be used to represent the various subsets of a sample space. So here, the entire Venn diagram, is going to represent my sample space of numbers 1 through 10. Okay, I have a circle that's just going to be for A. I have a circle that's just going to be for B. There's a little middle piece where they're going to share, like if a certain number falls in for both categories, it goes in the middle. And then we do have outside space if nothing fits any of them. Okay, so if we look at what our events were, so we have numbers less than 5 and even numbers. Well, 2 and 4 are both even numbers, and they're both less than 5. So those values go in the middle, okay, because they work for both situations. Then, in event A, I have the rest of my even numbers. So 6, 8, and 10. Those are even numbers, but they are not less than 5. B, are there any other elements that were less than 5 besides 2 and 4? Well, yeah, it's 1 and 3, right? Now, looking at those, was there any number not used? So that means a number that's not less than 5, a number that is not even. Oh, I am sorry. I need to write them down. So we have 1, 2, 3, 4. So 5 is going to be out here, right? 6 and 7. So 5, 7, and 9. Okay, these are not going to go into any of my circles because they're not even numbers and they are not less than 1. I mean less than 5, excuse me. Okay. So this is my completed Venn diagram. Sorry about that. Next questions. What elements are in A and B? Okay, everything in A, or the intersection of A and B, so it has to be in both. Well, that's going to be my little piece in the middle. This is the intersection of them. And it is written by using this like upside down U symbol. Okay, intersection. Think of an N. Okay, so the intersection of A and B are the elements of 2 and 4. Okay. What's going to be in A or B? Okay, so it's not the intersection anymore. It's just A or it's just B. So look in the A circle. My A circle has 2, 4, 6, 8, 10, right? My B circle has 2, 4, 1, 3. So these are all in A or B. So we have 1, 2, 3, 4, 6, 8, 10. Okay, union together, okay, all of it together, that's what union represents. Okay, so A or B, I look at all my circle A, I look at all my circle B, I include all values. A and B means just, it has to fit both of them. I can't do just A or just B. It's just the piece in the middle. All right, what elements are not in A? Okay, so what I like to do visuals, so not in A. So I'm going to kind of block out the circle A. Well, what's left over? Just 1 and 3, right? But don't forget, we had 5, 7, and 9 out here. And now that didn't get on the slide for you. So not in A, we have 1, 3. We also have 5, 7, 9 out here, not in a circle. So not A is going to be not even, right? If A was all the even numbers, not A means not even. This is called a tilde symbol, but we read it as not. Okay, this is a complement. So when we have that little tilde symbol, it's read as not A or a complemented A. So here A was even numbers, so not A means not even numbers. All right. My next one, remember to draw these in here because we might need them, who knows. What elements are in not A? That's union, right? Not A or B. Explain what this notation represents. Okay, so elements not in A or B. So that's the pieces that are not in the circles. Okay, if you go back, remember A or B, that was all the numbers in the circles, right? So the pieces that weren't in the circles were that 5, 7, 9. So if we're not in the union of A and B, so all of circle A and all of circle B, okay, if we're not in there, so if I cross these out, not A, not B, we're only left with the pieces of 5, 7, and 9. All right, I want you to pause and try the next piece. This is define two new events, C and D, so that the sample space, S, is the union of events of C and D. Okay, union means the circles together include all of your values. So pause and try. All right, so what did we come up with? So what events C and D could we come up with to include my values that are left over? Well, I could make event C odd numbers, and I could make event D, there we go, numbers that are going to be greater than 5. I should say than 5. Sorry, kind of got cut off. Greater than 5. So we have odd numbers, even numbers, and then numbers greater than 5. All right. All right, a very common example you will have is standard deck, okay? A standard deck of playing cards. So consider a standard deck of playing cards. There are 52 cards in a standard deck, okay? Half are red, which are hearts and diamonds, and half are black, which are spades and clubs. So these are all red. These are red. My line is not straight, and I'm sorry. And those are red. Okay, but the top two are black, but the bottom rows are red. All right. There are 12 face cards, jacks, kings, and queens. We're going to have the aces for this scenario be considered to be a value of 1. Okay, so we're going to let event A be the set of all red cards. Event B is going to be the set of even cards. And set C is going to be cards that are less than 5. And wants me to create a Venn diagram representing how many we have. Okay, so first things first. We got lots to go through. The set of red cards. Okay, so how many cards are red? Well, it looks like half of my deck is red, right? What does this do first? Okay, it doesn't go inside. So how many cards are red cards? So half my deck is red. That's going to be 26 total cards are red, right? How about just set B? How many cards are just even cards? Well, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 cards are going, oh, we're not counting queens, I'm sorry. 20 cards, we're not doing queens. 20 total cards are even. Set C, cards that are less than 5, okay? So that's this part, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cards are going to be less than 5, okay? So that's the total. I didn't write them inside the circles yet because I had to kind of see which of the 26 red cards might also be an even card or might also be a card less than 1, okay? So we got to look at what they all have in common with each other. So let's start from the middle. It's the best to work your way middle and then work your way out. Okay, so let's look at what cards are going to be red. I'm going to kind of get rid of this. What cards are red? They are even and they're less than 5. Okay, so red and even, less than 5. I got those two. Red, even, less than 5. That's it, right? So the 2 of hearts, 2 of diamonds, 4 of hearts, 4 of diamonds. So there are 4 cards that are going to be red and even and less than 5. Okay. Once I use them, I do cross them out because I can't use those 4 cards again. They're already being represented in the middle. Okay. Next, which way are we going to go? We're going to go up. Okay. So I'm going to go above the middle. Now I'm going to be looking at what do I have left that are red cards and they are even cards. Okay, red and even. So I'm going to stay down here. So we have my 6s, my 8s, and my 10s. That's 1, 2, 3, 4. That is 6 cards that are red and even. All right, cross them out when I use them. They're gone. Okay. All right, now I'm going to go down here between A and C. So that's going to be red cards that are also less than 5. So it's what's left. Red cards less than 5. Okay, so my aces are less than 5, my 3s, and that's it. So I have ace hearts, ace diamonds, 3 hearts, 3 diamonds. There's 4 cards that are red that are less than 5 that are left over. Again, once you use them, cross them out. All right, let's do the next little piece. Between B and C, so that's going to be even cards that are less than 5. So I don't care about red anymore. I just want to know even and less than 5. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. There's 8 cards left. Excuse me. I did that wrong, didn't I? It's just even cards. So I cannot include my ace. I can't include my 3. Even, less than 5. Okay, so it's 2, 4 of spades and clubs. Yes. Yep, there are 4 cards left that are even cards and less than 5. Cross them out. All right. So now let's look at what's left. So subset A was red cards. So I've already used, what, 18 cards? Out of what's left up here, how many of those are just red? Well, it's going to be all my hearts and all my diamonds. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 cards left that are just red. Okay. Cross those babies out. Can't use them anymore. Once it's used, you cannot use it again. All right, next, let's go over to part B. How many cards left are just even cards? Okay, when we look through my deck, we have my 6s, my 8s, and my 10s. That's going to be 6 cards left that are just even numbers. And cross them out. Can't use them anymore. Last but not least, what are the cards that are less than 5? So looking at what's left up here, less than 5, that's my aces, and that's my 3s. So there are 4 cards that are going to be less than 5. Cross them out. All right. I still have cards that haven't been picked, right? That don't fall into any of those categories. Okay, well, that's going to be the number that goes on the outside. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 12 cards that didn't fall into anything. Okay? 12 cards out here that don't fall into any of my elements. Okay? So look right here. At the very beginning, I'm going to go back a second. We said that there were 26 red cards, right? If I add up all the numbers in this circle A, they're going to add up to give me the 26. 12 plus 6 is what? 18. Plus 4 is 22. Plus 4 is 26. Good. So that's a way you can go back and check yourself that you didn't like count a card more than once that you weren't supposed to. Same thing with B over here. Even cards, we decided at the very beginning there were 20 even cards. So if I look in this circle, 6 and 6 is 12, plus 4 is 16, plus 4 is 20. I have 20 total even cards. Last but not least, let's check my subset C. These were all the cards that were less than 5. At the beginning we determined there were 16 cards less than 5. 4 plus 4 plus 4 plus 4 does give me 16. So there's always a way to go back and check yourself, okay? The numbers in that circle cannot go over how many total there were, okay? This can't magically go to 20. I can't have 20 cards less than 5 if only 16 cards less than 5 exist, okay? So make sure your numbers do add up. That's a good way to check yourself, all right? And then we do have 12 cards on the outside that didn't fall into any of the categories. Okay, how many elements are in the union of events A, B, and C? So union means all together, okay? If we are the teacher union is all the teachers working together, okay? Union is all of them. So everything in A, everything in B, and everything in C, right? So that's going to be 12, 6, 6, 4, 12, 6, 4, 4, 4, 4, 6. You're adding up every single number in all the circles, excuse me. So you're adding up everything that we use. 6, 4, 4, 4, 4, 6. All of these added up together gives you the 40 cards. There were 40 cards used. Okay, these are all the cards that were even, they were red, or they were less than 5. Okay, they fit in some part of my subsets. Next question, how many cards are in the set not A and B? Remember that upside down, that's an N, intersection, right? So what is not in the intersection of A and B? So look up here. Again, I'm a very visual person. I like to make markings. If you have a pencil, I would lightly mark this. Not in A and B. Well, here's A and B, right? Not in A and B. That's that little section right there, okay? I can't go all the way down. This is A, B, and C. Just cards that are only A and B is this little piece right here. So I'm going to take my 52 cards and take away 6 of them, okay? So this is going to include all the cards that are even, red, or less than 5. All right. So when you're shading your Venn diagrams, make sure you do it lightly, okay? Because obviously you want to be able to see what was there and go back to it. Or you can just do the Venn diagram. You can rewrite it over and over again if you need to do that as well. Okay. So not in A and B. I went to A and B intersection. It's just the 6. 6 cards are A and B. Cross those out. I can't include those, but everything else is up the game. So my total 52 cards minus the 6. All right. All right, the following results were found from a recent survey of 250 subscribers to a conspiracy theory website. Okay. 125 followers believe that we never landed on the moon. That's going to be set A. Excuse me. 175 followers believe that 9/11 was a government plot. That's set B. And then 65 followers believe that both theories are true. We'll just draw a Venn diagram to represent the situation. All right, so I have my sample space. We have our Venn diagrams. Okay. I'm going to go ahead and label one of those circles A, one of those circles B. All right, so how many total people believe we never landed on the moon? Okay, well, that was 125 people, right? So everything in my circle A should add up to give me 125. And then it said 175 believe that 9/11 was not, or was a government plot. So everything in circle B should add up to give me 175, right? 65 believe are both. We should start in the middle, work our way out. So 65 believe that both are true. So we're going to start with the middle with my 65. Okay. Now I'm going to put what's left. So of the 125, right? Of my 125 believers that we didn't land on the moon, I'm going to take away the 65 that also believe in 9/11. So I have 60 followers left that just believe that we never landed on the moon. All right? Same thing for part B. Of the 175 followers that believe 9/11 was a government plot, I'm going to take away the 65 that also believe we didn't land on the moon. That leaves us with 110. Okay? So how many is that? That's 110 plus 60 plus 65. That gives me 235. So how many followers didn't believe in any conspiracy theory? Well, it said I had a total of 250, right? So there were 250 subscribers, but only 235 believed in one of these. So if I take away 235, where does that leave me with? 15? So there are 15 followers that didn't believe in any of those theories. So I got 15 that are not going to fit into a circle. Okay. Once I add everything up, 60 plus 65 plus 110 plus 15, there's my total of the 250 subscribers. Okay, that's how we create a Venn diagram from the information. So get our totals, start in the middle, work our way out, and then don't forget to include whatever was left that was not part of a subset. All right? Here we go. Get my 15 back down here. All right, so how many people are in A and not B? Okay, so that means in my circle A and not in my circle B, not in B. So the intersection of A and not B. So here's A, right? Here's A, but I can't include any of B, so B is out. So what does that give me? It just gives me the 60 people. Okay, so all circle A, but not B. So I had to cross off my B's. Just 60 were left. All right? How many people are not in A and B? Okay, so again, we're including circle B this time, but it says and not A, so I cannot include A. That leaves me with just 110. All right. How many people are in not A and B? Okay, well, A and B is the intersection in the middle. So not that, we're going to take that away. Okay, so we have, there's two ways to do it. You could do the total 250 minus the 65. You could also add what's left over. So I could do the 60 plus the 110 plus the 15 gives me the 185. There's two ways to do this last one. Okay, your total minus what you scratched out, or you can add what's left. Just don't forget to include the people are not in anything. That's a very common mistake. All right. All right, new example. Math Nation surveyed 9 people, and here are the results. We have names, we have gender, and we have if they prefer cats or dogs. Right? 2 people are randomly chosen from the ones that were surveyed. Okay? So event A, both people chosen are female, or event B, 1 person who prefers cats and 1 person who prefers dogs are chosen. So they're saying when they pick the 2 people, what they're trying to compare is they are both female, or 1 prefers cat, one prefers dogs. That's the different subsets. All right. Choose the sets I have of too many times. Choose the sets of people that are in the complement of the intersection of A and B. Okay, so complement means not in the intersection. So remember, it's my in of A and B. Okay, not A and B. Well, A is that they're both female. right? B is that one prefers cats and one prefers dogs. So this means not both female and one dog, one cat. Okay, so it can't be that combination. If it's both females and both cats, we're good. Both females, both dogs, we're good. If there's a male in the mix, we're fine. What I cannot have the outcome of two females with one dog and one cat preference. Okay, that's what we're looking for. Let's look at Amy and Ashley. Amy and Ashley, they're both female. Okay. Let's look. Amy, where is it? Amy is cats. Ashley is cats, so we're good because they weren't both female and one dog, one cat. They were both female, both cats, so that's fine. Okay, the only thing I cannot have is both females with one dog, one cat. Next, I have Amy and Stephanie. So let's look here. So we already have two females, so if they like one of each, I can't include it. Okay, Amy has the cats. Stephanie has the dogs. Oh, there's one of each, so I can't include Amy and Stephanie. Okay. Brian and Ethan. Well, right away, that's two guys, right? So that's fine. That's not both female. Ashley and Ethan. Again, that's not both female, so that's fine. Darnell and Jose. Again, not both female. I can go ahead and check them off. Chelsea and Rachel. Okay, they are both female, so they may or may not qualify. Now I gotta see, do they like one of each? If they do, I can't check them off. If they both like cats or they both like dogs, I'm fine. So Chelsea is dogs, all right, and Rachel is cats. Oh, that was one of each. I cannot include them. Okay. So we were looking for combinations of people that were not both female and could not like one dog, one cat. Had to have both of those elements together. All right. Here we go. All right, 50 students were surveyed and asked if they are taking a social science, humanities, or a natural science course for the next quarter. 21 students are taking a social science course, 26 are taking a humanities course, 19 are taking natural science, 9 are going to do social science and the humanities, 7 are doing social science and natural science, 10 are taking humanities and natural science, 3 are taking all 3, and 7 aren't doing any. All right, now let's make a Venn diagram. There we go. So we got 3 courses, right? So we're going to need 3 circles. Okay, let's label them. We'll put on. Let's go ahead and label them: social science, humanities, natural science. If you labeled the circles differently, it is okay. It doesn't matter what you label, but you gotta label them. Okay. We always start from the middle out. Okay, always, always, always. Okay, so how many students are taking all 3 courses? 3 students are taking all 3 courses. So a 3 goes dead center in the middle. Okay, I'm also going to go ahead and put the totals. So there should be 21 of my social sciences. There should be 26 in the circle for humanities. And there should be 19 total taking the natural science. That's a little thing I like to do. Make sure all my numbers in those circles should add up. Okay, always start in the middle. Now we're going to work our way out. Okay, what comes next? All right, so let's look. So left, how many are doing humanities and social science? That is this one, right? 9 students are going to take social science and humanities. Okay, so why is there a 6 here? Well, because 3 of those are doing all 3, right? So 9 are doing it, but I already have 3 represented for all 3 courses. So I got to take the 3 out of the 9 to leave me with 6. All right. Next, we're going to do social science and natural science. So coming down here, 7 are taking both of those courses, but I already have 3 represented. So 7 minus 3 gives me 4. Okay, because this is social science and natural science, right? That's where those overlap. 3 plus 4 gives me 7. Okay. Now we're going to do social science and natural science. So over here, I lied. We're going to do humanities and natural science. I have 10 total. I already have 3 in here, so that means I'm going to have 7 left. All right. Okay. Now let's fill in the rest of the circles. So if 21 people, if 21 people were doing social sciences, what do I already have in my social science circle? I already have 6 plus 4 plus 3, that's 13, right? So I need 21 minus 13 gives me 8. So now all these numbers, 8, 6, 3, 4, should all add up to the 21 and they do. All right, let's go up. Everything in the humanities circle, all these numbers need to add up to give me 26. Well, I already have what? 16 there. 26 minus 16, we got 10 left. That are just going to do humanities and no other course. All right, so we did social science, we did humanities. All right, last, my natural science course has 19 total, but I already have, what, 14 represented, so that means there's 5 left over. So everything in the natural science circle all add up to give me 19. And then last but not least, there are going to be 7 students not taking anything. So that's going to be the 7 out here floating in the sample space. Those are the 7 students that aren't taking any of the science classes. They don't fall in any circle. All right, so again, the trick with the Venn diagrams is start with the middle and work your way out. Okay, that's a way to keep yourself in check. All right, so you have a worksheet to work on for today. For some reason, number 1, when you print it, the numbers don't print. It might be better for you at home. I don't know what's happening. But when I printed it here, the numbers didn't show up. Those are the numbers that you should use for number 1 on your worksheet. Work on that today and turn that in, and I will see you guys next time. Bye.